Hello, Geometry Crew. Welcome back to day two. So in day two of our review for the 10.6 to 10.7 test, what I wanted to do is just go over some problems that might give us difficulty, and then just others, and make sure we get at least like one problem of every type done in a review day like this. So we're actually not going to do the first one. I'm just going to write down the examples that we are going to do. So we're going to do 2, 4, 5, 7, 8, 10, 11, and 13. That way we get like one problem of every type done if you need that reinforcement. And that way we can also, just double check and make sure our factoring skills are up to par and whatnot. So you'll see me skip questions, and that's why. Instead of doing all 13 problems, we're just going to do these 8. All right, so let's start on example 2. Okay, so we have two chords formed inside the circle. Remember with these segment lengths, the product of the chords, the product of the parts of the chords are going to equal the product of the parts of the chords of chord 2. All right, so we have x plus 2 times 3x, and that should equal the product of the parts of this chord, which is 8 times 9. All right, so we distribute that 3x, and we get 3x squared plus 6x, and 8 times 9 is 72. Get everything over to one side. Right away you should know, okay, we got to get everything over to one side. This thing's a quadratic. We're probably going to have to factor or use quadratic formula or something like that. So we got to get everything over to one side. Now, this one in particular is difficult because, okay, next thing you might jump to is, all right, let's do this guess and check. Let's get it on. All right, but that actually doesn't work in this case. Okay, if we do that, we're probably going to miss something, which is the fact that this has a greatest common factor. All right, we got to factor out that greatest common factor and then try to factor. All right, so the greatest common factor here is 3. So if we factor that out, we get x squared plus 2x minus 24 inside that quantity. All right, and that actually helps us out. Now we got something that's a little simpler that we can try to factor. It may work, it may not work, we just got to see. Okay, so now from here, we know that's got to be an x, and that's got to be x to get us x squared. Now, the last parts of each binomial have to multiply to be negative 24, and then for the outer and inner parts of FOIL, we're going to have to get 2x. Okay, so in this case, we'd have positive 6 and negative 4. Now we can just set the factors equal to 0 and solve. So in this case, we set x plus 6 equal to 0, we get negative 6. All right, we set x minus 4 equal to 0, we get positive 4. In the context of the problem, we have to double check and see if both of these work. All right, really simple. We could plug negative 6 in right here. We'd get negative 18. That don't work. And we get x equals 4. Whew. So for our first example here, that's a behemoth there. All right, we're skipping 3, going on to 4. All right, so in this one we have the secant-secant relationship. So exterior times the whole of one secant segment, which would be x plus 2 times 2x plus 2, equals the exterior times the whole of the other secant segment. And now from here, we can do our thing. We can FOIL this first quantity out. All right, we're going to get 2x squared plus 6x plus 4. That's going to equal 40. And once again, we got to recognize we got to get everything over to one side. All right, so that means subtracting 44. Okay, so we get 2x squared plus 6x minus 36 equals 0. And like always, when we try to factor, we got to make sure to factor out a greatest common factor. In this case, we see that they're all even, so we know for sure that there's a greatest common factor. In this case, that greatest common factor is 2. So we have 2 times the quantity x squared plus 3x minus 18 equals 0. All right, and the benefit of factoring out that greatest common factor is that, guess what? We're going to get something a little bit simpler in here. All right, x squared plus 3x minus 18, that factors to be x plus 6 times x minus 3. Okay, a lot of times you might have to FOIL to figure it out. All right, you might have to FOIL this quantity to figure out whether it's equal to that quantity. Okay, now we're just going to set these factors equal to 0 and solve, so we get negative 6 and positive 3. All right, once again, we got to look at the picture. In the context of the problem, did these numbers make sense? Well, negative 6 doesn't. So we get x equals 3. All right, let's check out 5. All right, now we have a tangent-secant relationship. So tangent squared equals exterior times the whole thing. All right, so now we're going to multiply 45 squared. It's 2025. Now distribute 27. We get 27x plus 729. Get everything on over to one side. We do that, we get, sorry, I shouldn't say everything, the constants over to one side. We get 1296 equals 27x. All right, so we subtracted 729 to get that. Now we're going to divide by 27 to get x by itself, and we get 48. And of course, 48 here makes sense in terms of the context of the problem. All right, all the other examples that we're going to do are going to be over, the center, radius, graphing, circle. So it's about the equation of a circle. So we're skipping 6, going on to 7. All right, so it says identify the center and radius of each. Remember, we just got to recognize that this is a standard equation for a circle. So using that, we can find the center. Remember, the center is the point h comma k. All right, so our h value would be 8. Our k value would be 6. And then for our radius, we have the radius squared being 73. So all we got to do is take the square root, and we get the radius is the square root of 73. Not too difficult on those questions. All right, if we know the equation for a circle, then everything else is a little bit easier then. All right, if we take a look at 8, once again, we have the equation, so we got to recognize and associate the equation with the center and the radius, okay, of the circle. So this is the radius squared, that's 16, so that means the radius is 4. And then from there, we have to identify the center. Okay, it should be saying minus h and minus k. It doesn't say minus in that quantity with x. All right, so that means the x-coordinate's negative 3. And then the y-coordinate of the center is just positive 3. All right, so now we can just draw the circle. Okay, we got the center, which is at negative 3, comma 3. And then the radius is 4, so go 4 units to the right, 4 units to the left, 4 units up, 4 units down. I advise making these curves. I've got to focus when I do this, so I'm not very good at it. All right, and then just try to connect them in a circular fashion. Might not look good, but it's okay. We understand. Everybody's human. Not everybody's a great artist. All right. 3 more. So in 10, this is one of the most commonly missed questions when we get to this test. Okay, we have the center and the radius. Oops, that's not 10. Here's 10. The reason why I say this is one of the most commonly missed questions is because of how the radius is displayed. So it's 2 root 6. Okay, so we want to find the radius squared. So we have to take that quantity and we've got to square that quantity, and that means we've got to square both 2 and root 6, and we would get 4 times 6, which is 24. All right, usually what I see is a lot of people will just square 2. They won't square each factor inside that quantity, and that's what we got to do. All right, so in that case, we've got the center. Now we have the radius squared, so now we can write this equation. That's the quantity x minus 4 squared plus the quantity y plus 13 squared equals 24. Awesome sauce. Boom, accomplished. All right, next one. We've got the picture of our circle. Let's identify the center. Okay, all of the points on the circle should be equidistant from the center. So let's say, ooh, I marked the center over here. You know, I'd be able to figure out, wait a minute, that's not the center. You know, all those points are not equidistant. Here's our center point, 3, 0. All right, the radius is the distance between the center point and any point on the circle. That's 4. All right, so now we got the radius and the center. We can write this equation. That's going to be x minus the x value of the center, so x minus 3 squared, plus y minus the y value. Okay, well, the y value is 0. All right, so we don't need to subtract anything. We can just write plus y squared equals the radius squared. All right, the radius is 4, so 4 squared will be 16. All right, last one for number 13. So once again, skipping 12, going on to 13. What we're not told that we need to write the equation of the circle is the radius. So that's our first step. We got to find the radius. All right, so you could totally just straightforward use the equation. Okay, use the equation for a circle. Plug what you know in, and that will allow you to find the radius. Okay, you could totally do that, because then here's your h and here's your k value. So h would be -1, k is 2. All right, the point on the circle is just some x and y value. So you could plug those things in. I would just encourage, okay, the KISS process. Keep it simple, stupid. Okay, I call myself stupid all the time, so keep it simple. I'm talking to myself here. All right, so the difference between the x values would be 15. The difference between the y values is 2. So we have that difference between the x value squared plus the difference between the y value squared. I like to do this because it simplifies things. All right, it's a lot. Doing it otherwise is, I think, a lot of unnecessary work. All right, let's just use our understanding of what it means, like Pythagorean theorem and things like that. So 15 squared is 225. Got 225 plus 4, which is 229. Now we've got the center and the radius squared. So now let's write that equation. So we've got the quantity x plus 1 squared plus the quantity y minus 2 squared equals 229. All right, folks, like always, if you have any questions, please let me know. Email me, shout out to me, however you can. All right, let's get ready for that test. All right, folks, have a good day.